Hello, I am Mrs. Edwards, and today we are going to be using some properties, some that you're familiar with and maybe some others that you're not so familiar with, to answer all the other trig functions given the answer to just one of the trig functions. Please keep in mind that today when we go through these examples that we are going to assume that theta, the angle measure, is an acute angle. Eventually we will get to some examples in another lesson where theta can be any size at all, but for now we are assuming that theta is an acute angle. If you're in my class, you should be familiar with the reciprocal identities and the quotient identities. Quick review of those is sine goes with cosecant. It is not an alliteration. It's not S with S and C with C. Sine goes with cosecant, cosine goes with secant, and then tangent's reciprocal is cotangent. Okay, then tangent and cotangent, I've shown you how to get those, but tangent is essentially slope, rise over run. All points on the unit circle come in ordered pairs of cosine theta comma sine theta. And so if you do rise over run, that makes tangent sine over cosine. And then the reciprocal is cosine over sine. We're going to focus our time here at the beginning of this lesson on deriving the Pythagorean identities. Once we know all these identities, then we're going to use that to find the answer to all the other trig functions given the answer to one trig function. I think it's really important that you actually know where these identities come from, because it can, first of all, take a little bit of the memorization out, and hopefully you don't forget them as fast as you memorize them. All right, so let's get started with that first one. Sine squared of theta plus cosine squared of theta equals 1. This Pythagorean identity is actually very simple to show you. If you go to a unit circle and then go to just any coordinate on the unit circle, you would have an angle that goes through that point, known as theta, and then that point there on the unit circle, that's just an ordered pair, say x comma y. Then going from that point where the angle is going through on the unit circle, we're going to simply drop a line segment straight to the x-axis. So in this case, that'd be right there. And what we've done is we've created a right triangle, identifying the legs and hypotenuse of this right triangle. The hypotenuse is really the same as the radius of the circle. So the hypotenuse just has a length of 1. Now to plot a point, you go to the right x, and then you go right x, and then up y. So this distance here is x, and this distance here is y. If we just use the Pythagorean theorem with that green line segment being a length of x, the red line segment a length of y, and the hypotenuse a length of 1, substituting those values in, we get x squared plus y squared equals 1 squared, and just simplify 1 squared, we get 1. We are off to a good start, getting closer to this sine squared of theta plus cosine squared of theta equals 1. Because all points on the unit circle, the coordinates represent the answer to the cosine of theta, comma, the sine of theta. So if you know that points on the unit circle are cosine theta, comma, sine theta, and cosine of theta is the x, and sine of theta is the y, we make a quick substitution there, and there we have the first Pythagorean identity. You might be wondering, why is this squared out here and then over here it's kind of smashed in between? Well, they are equivalent to one another. Mathematicians are notorious for being lazy writers, and so they stick the little 2 in there so they can avoid writing all of those extra sets of parentheses. But I will kind of advise you that every time you see this shorthand notation for sine of theta times sine of theta, I would immediately write it as, say, sine of theta to the second power. And same thing here with cosine squared theta, write it as cosine of theta to the second power. That's going to make the algebra much easier. And frankly, as you move to calculus, you want to avoid this notation. As soon as you see it, you immediately change it to something to that exponent. Kind of like you really start to not care for the square root symbol, square root of x, and you write it as x to the half. Just little notation tips. All right, so how about that next one? If we want to derive 1 plus tangent squared of theta equals secant squared of theta, we can start with that last identity that we just created. Sine squared of theta plus cosine squared of theta equals 1. I'm going to take my own advice, and I do not care for that notation, so I'm going to immediately write that as the sine of theta squared plus the cosine of theta squared equals 1. Next, I'm going to divide both sides by cosine squared. If you divide both sides by cosine squared, dividing that left side by cosine theta squared is the same thing as dividing each term by cosine of theta squared. Now we just need to simplify each one of these terms. Let's start with that first term there. Let's start with sine of theta squared over cosine of theta squared. That should remind you of the quotient identity. Tangent of theta is equal to sine theta over cosine of theta. So if you squared both sides, that's the same thing as saying sine squared of theta over cosine squared of theta is equal to tan squared of theta. So I have the tangent of theta squared. Then the next term here, we have plus cosine of theta squared over cosine of theta squared. That's just 1 equal to, and then 1 over cosine of theta squared should remind you of the reciprocal identity. Secant of theta is equivalent to 1 over the cosine of theta. So if that's true and we squared both sides, the fraction 1 over cosine times 1 over cosine would be 1 over cosine squared. So we can replace that 1 over cosine of theta squared with secant of theta squared, and there we have the next Pythagorean identity. If we use that concise notation, I might rewrite it like that. Next, we'd like to establish 1 plus cotangent squared of theta equals cosecant squared of theta. We're going to start this exactly the same way, starting with sine squared of theta plus cosine squared of theta equals 1. I'm going to rewrite it just with a little different notation. Last time we divided both sides by cosine squared. Well, this time we're just going to divide both sides by the sine of theta squared. Remember, dividing that left-hand side by sine of theta squared is the same thing as dividing each term by the sine of theta squared. Now we'll just simplify, starting with that first term there. So the first term, sine of theta squared over sine of theta squared, that is just 1. Okay, plus, now cosine over sine should look familiar to you. That is a quotient identity. If we square both sides, then cosine of theta over sine of theta squared is cosine squared over sine squared. And so we're going to be able to replace that with the cotangent of theta squared. Now 1 over sine of theta squared, 1 over sine should look familiar. That is a reciprocal identity. So squaring both sides, 1 over sine theta times 1 over sine theta is 1 over sine of theta squared. So we're going to be able to replace that with cosecant of theta squared. And we have just established this Pythagorean identity. Okay, now that we finally have our old identities that we knew, and then also we've added on these Pythagorean identities, let's go ahead and use these identities to find the answer to a whole bunch of trig functions given just the answer to one trig function. In this problem, we would like to find the other 5 trig functions of theta. We're starting off knowing that the cotangent of theta is equal to 5. We're going to use the identities to find all of the other ones. I would strongly recommend as your go-to identities, as your reciprocal identities, it's kind of buy one, get one free. As soon as I know one, I just take the reciprocal and I have another trig function's answer. So in the case of cotangent of theta, the reciprocal identity for cotangent is tangent. So since cotangent of theta is 5, which is 5 over 1, using that reciprocal identity, I know the answer to tangent of theta is going to be 1/5. Next, I still need 4 more trig functions. It doesn't matter which one you decide to go for next. So for no particular reason, I am going to pick cosecant of theta. Now from here, to decide which identity that you want to use, you want to choose one that contains the trig function you're trying to find and one of the trig functions you know the answer to. So in this case, I'm going to use 1 plus cotangent squared of theta equals cosecant squared of theta, since I would like to know cosecant and I already know the answer to cotangent. Now I'm going to substitute in those known values, replacing the cotangent of theta with 5. Keep in mind one more time, cotangent squared of theta really means cotangent of theta multiplied by the cotangent of theta. So since cotangent of theta is 5, we have 5 squared. Okay, simplify that left side. 1 plus 5 squared is 26. And then to get cosecant of theta alone, we want a square root. So cosecant of theta is equivalent to root 26. I'm going to go right to my go-to identity, the reciprocal identity. The reciprocal of cosecant is sine. So if we know that cosecant is root 26 over 1, let's take the reciprocal, flip that over. So then sine of theta is 1 over root 26. I need to rationalize it just for my final answer. So notice I did multiply the numerator and denominator by the square root of 26 for my final answer to sine of theta. So start thinking, what are the other 2 trigs that we don't know yet? So we have 2 left, one of them being secant of theta. Again, it doesn't matter which one that you decide to go with. I just happen to randomly go with secant of theta. So let's start thinking of an identity that contains the trig function secant of theta and also contains one of the other trig functions that we know. I'm going to go with 1 plus tan squared of theta since I know the tangent of theta and I want secant of theta. Substituting in the knowns, tangent squared of theta becomes 1/5 squared. Simplifying the left-hand side, 1/5 times 1/5 is 1 over 25. And 1 plus 1 over 25 is like 25 over 25 plus 1 over 25. So we get 26 over 25. Lastly, to isolate secant of theta, we want to square root both sides. Keep in mind when you square root an entire fraction, that's the same thing as square rooting the numerator over square rooting the denominator. So when I take the square root of the fraction 26 over 25, that's like taking square root of 26 over the square root of 25, which ends up being root 26 over 5. Now that we have the answer to secant of theta, We're going to go to the reciprocal identity. The reciprocal identity for secant is cosine. So I am going to take the reciprocal of root 26 over 5, and that will be the answer to cosine. I do need to rationalize this, so I multiply the numerator and denominator by root 26 to get my final answer.